The fragment weighed maybe 3 kilograms, sharp edges, still smelled like cordite. Hauptmann Klaus Weber turned it over in his hands, noting the crude stampings, the simple welds, the almost laughable lack of precision. This was British engineering. This was what had stopped his Panther tank 2 days ago, penetrating 80 millimeters of frontal armor, killing his loader instantly, and forcing his crew to abandon a 50-ton machine that represented the peak of German industrial capability. He had been taught his entire life that German engineering was methodical, superior, destined to dominate through technical excellence. The twisted metal in his hands, recovered from a roadside in Normandy, where Corporal Fischer had died, was about to teach him something his instructors at the Panzer school had never mentioned. Sometimes the crudest weapon wins not because it is better engineered, but because it is better understood. This is the story of the PIAT, the Projector Infantry Anti-Tank, arguably the ugliest and most primitive anti-tank weapon of World War II. But it is really about the moment German armor doctrine collided with brutal mathematical reality, and what it reveals about the difference between sophisticated engineering and effective engineering, between what looks impressive and what actually works, between building weapons for parades and building weapons for killing. July 1944, Normandy, the Bocage country. Hauptmann Weber commanded a platoon of Panther tanks, the Panzer V, which on paper was superior to anything the Allies could field. 500 horsepower, 75mm gun with exceptional velocity, sloped armor that could deflect most Allied tank rounds. He had trained for 3 years on the principle that German armor, properly deployed, was nearly invincible to infantry. The Panther's frontal armor was designed to defeat anti-tank rifles, to shrug off anything a man could carry. Then came June 6th, and the weeks that followed, and Weber's company began losing tanks to something they rarely even saw. Not to Allied tanks, not to artillery, to infantry. At ranges so close the crew often died before they understood what had hit them. His company commander dismissed the first losses as bad luck, poor situational awareness, crew failure. Then it kept happening. Panthers immobilized, Tigers forced to retreat. Even the massive King Tiger, all 68 tons of it, vulnerable in the close terrain of the Norman hedgerows. The weapon responsible left fragments, twisted steel, sometimes unexploded projectiles that the recovery crews handled like religious artifacts, terrified and fascinated in equal measure. By mid-July, Weber's battalion had collected enough debris to send back to the weapons testing facility at Kummersdorf. What came back in the technical analysis would force an entire generation of German armor officers to confront an uncomfortable question. What if sophisticated engineering had made them predictable? What if the enemy's crude improvisation had made them adaptable? What if they had spent 5 years building tanks to fight the last war, while the British built weapons to fight this one? To understand what the Germans discovered, you first need to understand what they believed. German anti-tank doctrine in 1944 was built on a foundation of precision engineering and ballistic science. Their primary infantry anti-tank weapon was the Panzer, a rocket launcher derived from captured American bazookas. Effective, relatively accurate, required electrical ignition systems, precision machined components, carefully manufactured rockets. It worked because German engineering made it work. They believed this was how you built weapons. Precision, repeatability, technical sophistication that reflected the superiority of German industrial culture. The British PIAT, when German intelligence first encountered reports of it in 1943, seemed to confirm every stereotype about Allied inferiority. It was a spigot mortar, a medieval siege weapon concept adapted to fire a shaped charge. It had no rocket motor, no propellant in the projectile itself. It launched its bomb using a massive spring, like a crossbow designed by a madman. German engineers who reviewed the initial intelligence laughed. The British were so desperate, so resource-starved, so incompetent, that they were using springs to fight tanks. Springs. The laughter stopped in Normandy, when those springs started killing Panthers. Weber's first encounter with a PIAT happened on June 9th, 3 days after the invasion. His Panther was advancing through an orchard near Tilly-sur-Seulles, buttoned up, moving slowly through terrain that limited visibility to maybe 30 meters. The standing orders were clear. In close terrain, work with infantry support, never advance blind. But the infantry had been pinned down by British machine gun fire, and Weber's company commander was screaming over the radio about maintaining momentum, about not letting the enemy consolidate, so Weber advanced. The explosion came from his left, maybe 20 meters away from a position he had passed 10 seconds earlier. The sound was different from anything he had heard before. Not the whoosh crack of a Panzer, not the sharp report of an anti-tank gun, a hollow thump like someone hitting a massive drum, followed immediately by the sound of steel punching through steel. The Panther lurched. Smoke poured through the turret ring. His loader, Schütze Rolf Kellermann, 20 years old, from Hamburg, who collected photographs of his girlfriend and talked endlessly about opening a bakery after the war, made a sound that was not quite a scream. Then silence. Weber got the tank reversed, got it behind a stone wall, got his crew out. Kellermann was dead. The shaped charge had penetrated the side armor, thinner than the frontal plate, and the jet of superheated metal had essentially vaporized everything in a cone from the point of impact. They never saw the shooter. British infantry recovered the position an hour later. All Weber found was a crater in the hedgerow, some disturbed earth, and a smell he would never forget. Cordite and wild garlic and turned soil, the smell of being outfought by an enemy using weapons that should not have worked. The fragments recovered from that engagement, and dozens of others went to Kummersdorf, where engineers with doctorates and years of ballistics experience examined them with increasing disbelief. The PIAT bomb was simple, absurdly simple, a hollow charge warhead on the end of a steel rod that fitted over a spigot, basically a fixed pin in the launching mechanism. When fired, the massive spring drove the spigot into a shotgun shell at the base of the bomb, which provided just enough impulse to throw the 3-kilogram projectile forward at roughly 130 meters per second. Once the bomb left the launcher, a small propellant charge in the tail armed the fuse and added minimal additional velocity. That was it. No complex guidance, no precision machining, no electrical systems. A spring, a spigot, a shotgun shell, and a hollow charge. What made German engineers deeply uncomfortable was not that it was simple. It was that the simplicity was brilliant. The PIAT had almost no working parts to break. It could be manufactured in workshops that had never built weapons before. It required no batteries, no complex ammunition supply chain, no specialized training to maintain. A soldier could drop it in mud, in water, leave it in freezing rain, and it would still fire. Try that with a Panzer, and you would spend an hour cleaning electrical contacts and checking ignition circuits. The shaped charge itself was basic physics, but physics applied with ruthless efficiency. The hollow cone lined with copper, when detonated, formed a jet of molten metal moving at something like 7,000 meters per second. At the ranges, British infantry were engaging tanks in Normandy, 10 to 30 meters. It could penetrate 100 millimeters of armor plate. That was enough to defeat the side armor of any German tank. It was enough to penetrate the frontal armor of most German tanks if you hit the right spot. Weber received the technical briefing in late July, after his company had been pulled back for refit. They had lost 6 Panthers in 3 weeks, 4 to PIATs. The briefing officer, a major from the weapons school, stood in front of a map of the bocage and explained with the careful diction of a man delivering bad news to people who outranked him. The PIAT was most effective at ranges under 30 meters. The British infantry doctrine was to let German armor advance into kill zones, pre-positioned firing points in hedgerows, buildings, anywhere with cover and limited German sightlines. The PIAT team, usually 2 men, would wait until the tank was nearly on top of them. 1 shot, side armor if possible, rear if they were lucky, frontal if they had no choice. Then immediate withdrawal, because the backblast and noise made the position obvious. British infantry were abandoning the launchers after 1 or 2 shots. The PIAT weighed 15 kilograms. They could not carry them during rapid retreats. Did not matter. The launchers were so cheap, so simple to manufacture, that the British simply issued more. Use it, drop it, get another one. This was the part that made Weber feel something shift in his understanding of warfare. The Germans had built the Panzer to be maintained, serviced, kept in unit inventory, like a valuable asset. The British had built the PIAT to be disposable, not because they were wasteful, because they understood that in the kind of close-range, sudden violence infantry fighting that characterized Normandy, survival mattered more than preserving equipment. A soldier who dropped a PIAT and ran could be given another PIAT. A soldier who tried to retreat while carrying 15 kilograms of awkward metal tube was a dead soldier. The technical analysis included test firings. German weapons testers at Kummersdorf had acquired 2 intact PIATs, probably captured in North Africa or Italy, and had run them through systematic evaluation. What they found was a weapon that violated every principle of German weapons design and worked anyway. The cocking mechanism required approximately 90 kilograms of force. Soldiers had to lie on their backs, place their feet on the cocking lever, and use their entire body weight to compress the spring. This was not efficient, it was exhausting. After 5 or 6 shots, most soldiers were too tired to cock the weapon again. German engineers noted this as a critical flaw. British soldiers used it anyway, because 5 or 6 shots at a tank was 5 or 6 more chances than they had without it. The accuracy was terrible by German standards. Effective range maybe 100 meters, realistically more like 50. No rifling, no stabilization. The bomb tumbled through the air like a thrown brick. German testers, accustomed to weapons that could hit targets at 300-400 meters, logged this as unacceptable. British infantry used it anyway because they were not engaging tanks at 300 meters. They were engaging them at 20. At 20 meters, accuracy was not the problem. At 20 meters, the problem was getting that close without being killed by machine gun fire. Having the nerve to wait until a 50-ton monster was almost on top of you, and pulling the trigger before your nerve broke. The PIAT solved the second half of that problem. British infantry tactics solved the first. Weber's company received updated tactical guidance. Do not advance without infantry support. Never. Period. In close terrain, use infantry to clear positions before armor advances. Maintain spacing between vehicles. Button up, yes, but have one crewman maintain observation, even if it means vulnerability to small arms. The implication was clear. German armor doctrine, developed for sweeping maneuver warfare on the Eastern Front, for long-range engagements across open terrain, had made them predictable in close country. British infantry had adapted. German armor had not. This was the cognitive dissonance, the mental static. Weber and his fellow company commanders had spent years being told that German tactical doctrine was superior because it was based on professional military analysis, on the lessons of Poland and France and Russia. Now they were being told that the enemy, the British, who German propaganda characterized as hidebound, unimaginative, addicted to outdated tradition, had out-adapted them. The British had looked at the bocage, looked at their available weapons, and concluded that expensive precision was less valuable than cheap availability. They had created a weapon that could be manufactured by the thousands, issued to every infantry section, used and abandoned and replaced. The Germans had created weapons that required specialized crews, careful maintenance, secure supply chains. Both approaches worked, but in Normandy in the summer of 1944, in terrain where tanks could not maneuver and infantry could get within 20 meters before being spotted, the British approach worked better. This is the part of the story where we need to slow down and understand something about organizational psychology. When you have built an entire military doctrine around technical superiority, when you have trained your officers to believe that German engineering excellence will deliver victory, when your national identity is wrapped up in the idea of precision and discipline overcoming improvisation and chaos, evidence that contradicts that belief does not feel like information. It feels like betrayal. Weber remembered a conversation in the officers' mess after the briefing. His friend, Lieutenant Dietrich Müller, commanding the 3rd Platoon, stared at his coffee and said something that Weber would remember for the rest of his life. "They are beating us with springs and scrap metal. What does that say about everything we have been told?" No one answered him. The question was not rhetorical, it was genuine. If a crude British spring launcher could defeat the Panther, arguably the best medium tank in the world, what did that mean about German armor superiority? If British infantry, using weapons that looked like they had been designed by amateurs, were outfighting German infantry, who had been trained to believe they were the most professional soldiers in the world. What did that mean about professionalism? The answers were uncomfortable. So most officers did not pursue them. They blamed tactics. They blamed terrain. They blamed the quality of replacement crews. Anything except the underlying assumption that sophistication equals effectiveness. The PIAT was not a better weapon than the Panzer in any objective sense. The Panzer had longer range, better accuracy, more penetration. What the PIAT had was better fit. It fit the terrain. It fit the British manufacturing capacity. It fit the way British infantry actually fought, as opposed to how theorists thought they should fight. It was a weapon designed for reality, not for demonstrations. German weapons testers at Kummersdorf produced a final report in August 1944. Weber never saw the full document, but the conclusions filtered down through briefings. The PIAT was effective because it was simple. It was available because it was cheap. It was used aggressively because soldiers knew they could abandon it without consequence. The report recommended developing a German equivalent, something simpler than the Panzer, easier to manufacture, more disposable. Nothing came of it. By August 1944, Germany was losing the industrial war. There was no capacity to develop new infantry weapons. The factories were being bombed. The resource base was shrinking. Even if they had designed a better weapon, there was no way to build it in sufficient numbers. The British had been building PIATs since 1942. By 1944, they had issued something like 100 Uhrsäuren of them. Every infantry section had at least one. German infantry in Normandy were lucky to have one Panzer per platoon. Weber survived Normandy. His company did not. They lost 15 Panthers between D-Day and the end of August, 4 to Allied tanks, 3 to anti-tank guns, 2 to airstrikes, 6 to infantry anti-tank weapons, mostly PIATs. When the survivors retreated across the Seine, Weber's remaining crew talked about the bocage the way you talk about a nightmare. The close terrain, the inability to see threats until you were in kill range, the psychological weight of knowing that every hedgerow, every stone wall, every damaged building might contain a British infantryman with 15 kilograms of spring-loaded death. The technical superiority of the Panther meant nothing at 15 meters. The training and professionalism of the crew meant nothing if they were advancing blind. The entire structure of German armor doctrine, built on the assumption that tanks would fight tanks and infantry would fight infantry, had collapsed in terrain where everyone fought everyone at ranges, where sophistication mattered less than aggression. Weber was reassigned to a training unit in October. He spent the last months of the war teaching teenagers to drive Panthers, knowing that most of them would be dead within weeks of reaching the front. He never mentioned the PIAT to his students. What would he say? That the enemy had beaten them with a crude weapon because the enemy had understood something fundamental that Germany had not. That engineering excellence was not the same as battlefield effectiveness. That sometimes the side with the simplest, cheapest, most unglamorous weapon wins because they have more of them, and the will to get close enough to use them. The psychological aftermath of technological confidence colliding with brutal reality is difficult to articulate. Weber was not a philosopher. He was a tank commander, but in the years after the war, he would think about that fragment of PIAT bomb casing he had held in Normandy and what it represented. German industry had built the Panther to be superior. Technically, it was. Thicker armor than a Sherman, better gun than a Cromwell, more sophisticated than anything the Soviets fielded. But the British had not tried to out-engineer the Panther. They had made it irrelevant by changing the terms of the fight. They had pulled German armor into terrain where it could not leverage its advantages, then killed it with weapons so simple that German engineers had initially dismissed them as jokes. This was the lesson. Sophistication is only valuable if the enemy fights on your terms. The British refused. They fought on terrain that negated German advantages, with tactics that exploited German assumptions, using weapons that were designed for how warfare actually happened rather than how it was supposed to happen. The PIAT was a terrible weapon if you judged it by the standards of a weapons testing range. Awkward, inaccurate, exhausting to use, barely controllable. It was a devastating weapon if you judged it by the only standard that mattered. Did it kill tanks? Yes. At what cost? Cheap enough to issue by the thousands. That was all that mattered. There is a broader truth here about human conflict and the nature of effectiveness. We are drawn to sophistication. We admire precision, elegance, technical excellence. These things are genuinely valuable, but they create a psychological trap. We begin to believe that the most sophisticated solution is the best solution. We design for perfection rather than for reality. We create weapons or systems or organizations that work beautifully under ideal conditions and fail under actual conditions because actual conditions are messy and chaotic and do not care about elegance. The British designed the PIAT for messy chaos. It was ugly. It was crude. It was brutal to operate. It worked. The Germans designed the Panzer for professional soldiers operating in doctrine-approved scenarios with proper support. It was sophisticated. It was elegant. It required infrastructure that did not exist in Normandy. The terrain did not cooperate. The tactical situation did not match the planning. The British adapted faster because their weapon required less infrastructure to employ. This is not an argument against sophistication. It is an argument for understanding the difference between theoretical superiority and practical effectiveness. Weber's final encounter with the PIAT happened in April 1945, but not in the way you would expect. The war was ending. His training unit was being disbanded. He was sitting in a cafe in a town whose name he could not remember, waiting for the American advance, when a British officer sat down across from him. The officer spoke reasonable German. They talked. Eventually, the conversation turned to tanks. The British officer had been infantry, Normandy. He had carried a PIAT. Weber asked the question he had been wanting to ask someone for a year. Why did you use that weapon? It looked impossible to use effectively. The British officer smiled, the tired smile of someone remembering things he would rather forget. He said, "Mate, it was impossible to use effectively. Absolutely horrible weapon. Hated every second of carrying it. But I will tell you what it did. It gave us a chance. Your Panthers, your Tigers, they were better tanks, no argument. But if you got one of those monsters within 20 meters of us, and we had a PIAT, we had a chance. Maybe 1 in 3, maybe 1 in 4, but a chance. Without it, we had nothing. You do not win battles with perfect weapons. You win battles with weapons that give your soldiers a chance and the training to take it. We had both." The conversation stayed with Weber. It crystallized something he had been circling around for months. The PIAT was not a good weapon. It was a necessary weapon. The British had understood that necessity was more important than quality, that having something was more important than having the best thing, that fielding a weapon that was available and usable immediately was more valuable than waiting for a weapon that was perfect. Germany had spent the war building perfect weapons that arrived too late or in insufficient numbers. The Tiger was superior to the Sherman. Germany built 300 of them. America built 50 00 Shermans. The Panther was superior to the Cromwell. Germany built 6 00 of them while fighting a multi-front war with a collapsing industrial base. Britain built 4 000 Cromwells and focused on giving their infantry weapons that could kill German armor at close range. In the calculus of total war, quantity and availability and simplicity were strategic advantages. Sophistication was a luxury. This is what the fragments of the PIAT revealed to the German officers and engineers who studied them. Not just the technical details of how it worked, but the philosophy behind it. The British had accepted imperfection in pursuit of availability. They had embraced crude effectiveness over elegant theory. They had designed a weapon that frontline soldiers could use, maintain, and abandon, rather than a weapon that required specialists and infrastructure. In doing so, they had created something that terrified German tank crews more than any Allied tank. Because tanks could be avoided, outmaneuvered, outgunned, the PIAT could be anywhere. It required almost no signature before firing. It could be set up in 30 seconds. It turned every hedgerow, every building, every depression in the ground into a potential killing position. German tankers in Normandy developed something approaching paranoia about close terrain, because they knew that somewhere in that terrain, invisible until the last moment, was a British infantryman with a spring-loaded tube and the willingness to wait until a tank was close enough to touch. That psychological pressure was as effective as the weapon itself. It slowed German advances. It forced German armor to wait for infantry support that often did not arrive. It made tank commanders cautious. in situations where boldness might have succeeded. The PIAT was a force multiplier, not because it killed every tank it was fired at, but because the threat of it changed how German armor operated. In the decades after the war, military historians would analyze the PIAT as a footnote. Primitive technology, quickly superseded by rocket launchers and recoilless rifles, but the soldiers who faced it remembered it differently. They remembered it as the weapon that made every advance terrifying. The weapon that proved infantry could fight armor on nearly equal terms if they had the nerve and the right tool. The weapon that killed friends and destroyed expensive machines using springs and stamped metal and industrial-era physics. Weber never reconciled the contradiction at the heart of his experience. He had been an excellent tank commander. His crew had been well trained, his Panzer had been a superior machine, and he had lost friends to a weapon that should not have been effective, wielded by soldiers who German doctrine said should not have been a threat. The only resolution he found was to accept that warfare does not care about should, it cares about what works. And in Normandy in 1944, what worked was not sophisticated engineering or tactical doctrine or professional excellence. What worked was British infantry getting close enough to German armor to use a crude spring launcher, and having enough of those launchers that the odds eventually favored them. That was the lesson of the PIAT. Not that simplicity is always better than sophistication, but that effectiveness is contextual, that the best weapon is the one that fits the situation, and that sometimes the crudest solution is the right solution, because it is the only solution that can be deployed at scale under actual combat conditions. The fragments of the PIAT that Weber held in Normandy, that German engineers examined at Kummersdorf, were pieces of a weapon that should not have mattered, but they mattered because they were numerous, because they were available, because they gave frontline soldiers a tool that worked when nothing else did. In the end, that was enough. More than enough. It was the difference between a German army that believed its own propaganda about technical superiority and an Allied army that focused on what actually killed the enemy. One approach looked impressive, the other approach won. Think about that the next time someone tries to sell you on sophistication over effectiveness, on elegance over availability, on theoretical perfection over practical reality. The British did not build a better anti-tank weapon than the Germans. They built an adequate weapon and made 100 aus one of them. In the mathematics of total war, adequate multiplied by 100, 0 beats superior, multiplied by not enough. That is what the Germans learned from the fragments of a crude spring launcher recovered from French hedgerows. That is what those fragments, twisted metal and bitter revelation, still teach us about the gap between what we think should work and what actually does.